Welcome to This Explainer. I am absolutely thrilled to be your guide today on what's really an epic adventure through the deeply human history of mathematics. And hey, we aren't starting in some stuffy classroom today. No, we're starting right down in the dirt, and from there, we're going to ascend into the profound realms of abstract philosophy. So let's just dive right in.
So, how exactly did humanity get from counting cows with pebbles to literally inventing zero? I mean, it seems like an impossible leap, right? But let's put ourselves in the shoes of our ancestors for a second. Imagine you're living thousands of years ago in a small agricultural settlement, right along the lush banks of the ancient Saraswati River. Every morning, your precious herd of cattle wanders off into the dense forest to graze, and every evening they return. But here's the catch. You don't actually have any words for numbers yet. No written symbols, nothing. So how do you make absolutely sure that a calf hasn't wandered off during the day? Well, early humans solved this massive logistical problem with a stroke of absolute simple genius. It's called one-to-one correspondence. Basically, for every single cow that left the settlement in the morning, the herder would drop one pebble into a clay pot. Then, in the evening, for every cow that returned, one pebble was taken out. If that pot was empty at the end of the day, boom, you could sleep soundly. The whole herd was safe. If a few pebbles were still sitting in there, well, you knew exactly how many cows were missing. This brilliant, tactile pebble matching method literally gave birth to the natural numbers, 1, 2, 3, 4, that we still use every single day. Okay, moving on to part 1, mathematics written in bone. Way before we had paper or, digital tablets, our ancestors were actually leaving us the very first mathematical records, carved directly into bone. And this artifact brilliantly illustrates just how far back our mathematical heritage really goes. Deep in the heart of Africa, between South Africa and Swaziland, anthropologists discovered the Lobombo bone. Now, we are talking about an artifact that dates back a staggering 35,000 years. It features 29 distinct, deliberately carved, and uniformly sized notches. Experts believe this wasn't just some random scratching. It was a highly functional tool. It was likely a lunar phase counter or perhaps a menstrual calendar. The Lobombo bone is hard, physical evidence that human beings have been tracking time and using natural numbers for tens of thousands of years. But even more fascinating is the Ishango bone. This was found near the headwaters of the Nile River in the Democratic Republic of Congo, and it dates back to around 20,000 BCE. Now, unlike those simple counting tallies we just talked about, this bone contains columns of asymmetrical notches grouped in a highly specific, very deliberate way. It's basically a mathematical marvel just hiding in plain sight. Now, let's figure out a little puzzle together, just like a mentor and a student. Examine this sequence of numbers, carved by a human hand tens of thousands of years ago. 11, 13, 17, and 19. Take a second. Can you spot the mathematical pattern connecting them? If you guessed prime numbers, you absolutely nailed it. The Ishango bone specifically groups the prime numbers that fall between 10 and 20. And if we were to continue that sequence, the next 3 numbers would naturally be 23, 29, and 31. So the crucial takeaway here is that this artifact practically proves that the abstract concept of a number and actually understanding the relationships between numbers existed way before recorded history. All right, let's shift gears to part 2. Trade, astronomy, and numbers. As early humans settled into more advanced urban civilizations, the simple counting of cows or days of the moon, well, it just wasn't enough anymore. We start seeing this massive expansion in how humans thought about quantity. Over in the Indus Valley Civilization, places like Lothal on Harappa developed highly standardized weights and measures. These were absolutely essential for trading goods like terracotta and lapis lazuli with Mesopotamia. Meanwhile, during Vedic times, Indian philosophers started pondering these massive, mind-boggling cosmic quantities. They were giving specific names to powers of 10 all the way up to 10 to the 12th power, a number they called Parartha. By the 4th century BCE, we even see the Buddha describing numbers up to 10 to the 53rd power. That's a quantity called talakshana. Basically, society was demanding a really robust, incredibly expansive number system. So, let's put our ancient mercantile skills to the test with another problem from our explainer sources. Imagine you are a merchant in the bustling ancient port city of Lothal. You've just negotiated a killer trade. 15 copper ingots for every 2 bags of spices. If you bring 12 bags of spices to the market today, how much copper do you get to take home? Okay, let's break this down step by step. First, we need to find out how many batches of 2 bags we actually have. So 12 bags divided by 2 gives us 6 batches. Next, we multiply those 6 batches by our exchange rate, which is 15 ingots per batch. 6 times 15 yields exactly 90. So you, the savvy lawful merchant, get to leave the market with a hefty 90 copper ingots. Excellent work.
Now we arrive at part 3, the philosophy of emptiness.
You see, this growing comfort with immense numbers and complex trade set the stage for what is arguably the most important mathematical leap in human history. And amazingly, it didn't start as math at all. It began as a spiritual philosophy. In ancient Indian traditions, stretching all the way back to the Upanishads and early Buddhist literature, there was a deep, profound reverence for a concept called shunyata. As defined, this is a state of complete emptiness or nothingness. The whole goal of meditation was to empty the mind of all fluctuations or vrittis to achieve this perfect tranquility and stillness. And because these ancient Indian thinkers so highly valued this state of emptiness, they possessed the unique conceptual and cultural framework necessary to accept nothingness not just as a blank space or an absence, but as an actual tangible thing.
Which brings us to part 4, Brahmagupta's rules of zero. Now, this is exactly where history pivots. That philosophical concept of a void physically transitioned into mathematics in the ancient Bakshali manuscript as a bold dot, a placeholder known as a bindu. But, a symbol is really just a mark until someone gives it rules. Enter the brilliant mathematician Brahmagupta in 628 CE. In his seminal text, the Brahmasphutta Siddhanta, he explicitly transformed this philosophical void into a fully operational number. He defined zero perfectly as the result of subtracting a number from itself. Then, he laid down the absolute bedrock laws of math. Adding zero to a number leaves it unchanged, and subtracting zero leaves it unchanged. Furthermore, by truly understanding zero, Brahmagupta was able to formally introduce negative numbers to the world. He categorized positive numbers as fortunes and negative numbers as debts or rina. He literally unlocked a whole new dimension of mathematics.
And finally, part 5, the mentor's math quiz. We have traveled an immense distance today, haven't we? From matching pebbles all the way to the lofty heights of algebra. Now, as your mentor, it's time for you to take the reins. Here's your first challenge, and I want you to literally try this right now, wherever you are. Ancient Indians didn't just count on their fingertips, they counted using their finger joints. Open one hand. Now, use your thumb as a pointer. Count the 3 joints on your index finger, then the 3 on your middle finger, and so on across your 4 fingers. What number do you reach? Give it a try. You'll find you reach exactly 12. This simple biological reality on a single human hand is actually a foundational reason why ancient cultures developed base 12 counting systems. How cool is that? It's math woven directly into our own anatomy. And finally, I want to leave you with this provocative thought to ponder on your own. We know that natural numbers, our positive counting numbers, are closed under addition, right? Meaning if you add 2 natural numbers, you always get another natural number. But what about subtraction? What happens if you try to subtract 10 apples from a basket that only has 5? Suddenly our natural numbers break down. They just aren't enough anymore. So to solve this, what new dimension of math do we cross into? Hint, think back to Brahmagupta's debts. I really hope this explainer has sparked your curiosity to explore the incredible, never-ending journey of numbers. Keep questioning, keep learning, and I'll see you next time.